Welcome back to Hardware Unboxed. Today's video is one that I've been very excited to make for the last 6 months, ever since AMD officially announced their Ryzen Mobile 4000 lineup. The original plan was to have already tested most of the U-series parts by now, including the flagship Ryzen 7 4800U. Originally, we were supposed to be getting review units way back in March, but thanks to this pesky pandemic, it's only now that companies are finally starting to ship Ryzen 4000 Ultra portables in serious volume, so it's been a long process to get this testing done. This benchmark video is all about the Ryzen 7 4800U, AMD's top-of-the-line U-series APU for low-power, thin and light notebooks. This is the best AMD's Renoir die has to offer from an efficiency standpoint, aiming to bring class-leading performance to 15W and 25W power envelopes. We already know how well Zen 2 scales up to higher TDPs in the H series. Parts such as the Ryzen 7 4800H have seriously impressed me, but this sort of performance that's possible in top-tier ultra portables has remained unclear. Let's quickly recap the specifications of the Ryzen 7 4800U. We've talked a bit about the Renoir die before, so let's go into it all again. The 4800U is using a fully unlocked die with all 8 CPU cores active and all 16 threads. We're getting 8MB of level 3 cache and clock speeds up to 4.2 GHz in a low thread boost state. The base clock of 1.8 GHz is lower than other parts, as AMD needs to fit 8 cores and 16 threads into a 15W TDP rating. The GPU is fully unlocked as well, so we're seeing all 8 Vega compute units enabled, with clock speeds up to 1750 MHz. 8 Vega CUs means 512 shaders, a reduction on last generation Ryzen parts, but compensated for with higher clocks. The entire chip is a monolithic die built on TSMC's 7nm technology, and of course the CPU cores are based on the Zen 2 architecture. The test system for today's video is the Lenovo IdeaPad Slim 7, a premium slim and light 14-inch system that has a really nice metal chassis and overall build quality. Like most of our APU benchmark videos, this isn't a review of the laptop itself, but in my short time with it, I've been pretty impressed. This isn't your classic OEM puts Ryzen in a mid-range system situation. This machine should be rivaling the best out there. In any case, what we have is the Ryzen 7 4800U and 16GB of LPDDR4X memory in a dual-channel configuration. Ryzen supports both DDR4 3200 and LPDDR4X 4266. Our previous testing has been with DDR4 configurations. This laptop gets the full LPDDR4X treatment. There's also a good quality 1080p display, 512GB of PCIe storage and a 60Wh battery. I don't have pricing for this configuration, but I'd expect it to be around the $1,000 mark. Like all of our laptop testing, we are sticking to stock power configurations where possible, which allows for an apples-to-apples performance comparison where the laptop's cooler and power settings are removed as variables as best as possible. This is so you guys have a more generalized look at performance that applies to many laptops, rather than a focused look at how one laptop performs. So for today's testing, we'll be looking at performance with long-term power limits of 15W and 25W. In reality, the IdeaPad Slim 7 can sustain above 25W for quite some time in its maximum power mode, which is an impressive feat for this sort of laptop. But again, to keep everything equal, we'll be looking at 15W and 25W performance. That said, both modes we're testing still have strong boost behavior in keeping with how most Ryzen laptops that we've tested actually operate. This means a boost level up to 35W or so for around 5 minutes at 25W and 2.5 minutes at 15W. This is a much longer boost period than Intel's U-series processors, but this is by design. AMD intends to push boost for as long as is feasible to deliver maximum performance. Usual notes also apply for our benchmark charts. The numbers are an average of results from laptops running in the same configuration. The full list of laptops we tested are in the description, and there are lots of them. We also stick to apples-to-apples testing, so everything is tested with dual-channel memory and without thermal throttling. Let's start with Cinebench R20, the standard benchmark for CPU testing. At 15W, the Ryzen 7 4800U is an incredibly fast processor. We're seeing performance here that matches the Ryzen 5 4600H, a 6-core 45W SKU, while outperforming Intel's 45W parts such as the Core i7 10875H in the multi-thread test. This is absolutely insane levels of performance, allowing the 4800U at just 15W to deliver workstation-like results. It also means the Ryzen 7 4800U demolishes every Intel U-series part in the charts, and it's not even close here really. The 4800U at 15 watts is over 150% faster than the Core i7-1065G7, Intel's best Ice Lake processor at 15 watts. Granted, the 1065G7 has just 4 cores, but AMD's smart decision to enable 8-core designs in a laptop form factor has paid off big time here. We're also seeing double the performance of the best Comet Lake CPU, the 6-core Core i7-10710U. The margins are a little narrower at 25 watts. The 4800U is just 130% faster than Ice Lake and 70% faster than Comet Lake, but still, these are margins that are practically unheard of in mobile computing. AMD is also able to universally hold the Cinebench R20 single-thread performance crown in the U-series market. Margins here aren't anywhere near what they are for multi-thread as you might imagine, but we're seeing up to a 10% lead on the i7-1065G7 and 15% on the i7-10710U. This is not a situation where AMD are using more cores to get the performance win. The 4800U is faster whether you are using 1 thread or 16 threads. Performance is also remarkably impressive in some of our longer workloads like Handbrake, which takes at least half an hour to encode our X265 sample video. The 15-watt 4800U is offering close to the performance of Intel's Core i7-10875H, and it beats the overall fastest CPU Intel has in their entire mobile lineup, the Core i9-10980HK. Again, the 4800U is really an H-series sort of CPU in terms of performance, or at least completely redefining what we should be expecting out of the U-series. Once again, Intel's U-series processors get embarrassed. The 4800U is over twice as fast as the Core i7-10665G7 at both 15 and 25 watts. Meanwhile, we're seeing at least 70% better performance than the Core i7-10710U with an 88% lead at 15 watts. Similar story with Blender. Now, Intel would tell you this isn't a real-world benchmark as you wouldn't run Blender on an ultra-portable laptop, but with the performance AMD is offering here, I think that needs to be reconsidered because once again the 4800U trades blows with H-series parts. You definitely wouldn't want to use Blender on a Core i7-10665G7 laptop, but the 4800U offers well over twice the performance, so that changes things. Of course, GPU acceleration still makes H-series laptops attractive for workloads like this, but as a highly portable workstation APU, the 4800U makes for a compelling option. One sort of task you definitely would want Ryzen for is code compilation. When compiling Chromium, the Ryzen 7 4800U is about 70% faster than the Core i7-10665G7, whether you test in a 15-watt or 25-watt configuration. In fact, the 4800U is just as fast at 25 watts as a Core i7-10875H at 45 watts. Similar margins for GCC compilation, Ryzen is simply much faster for coding. Let's get into some lighter productivity workloads now, which is perhaps more important for a U-series device. In our Microsoft Excel number crunching benchmark, Ryzen still holds a huge performance lead on Intel's Ice Lake processors. We aren't quite in H-series territory with the 4800U here, but we do get close, and certainly this is the fastest 15-watt CPU on the market. For PC Mark 10's productivity test, which is lightly threaded, the results we saw in Cinebench R20 single thread come to play. The 4800U is 12% faster in this benchmark than the Core i7-10665G7, which is really a best case scenario for Intel's U-series. And these margins carry over into the Essentials test, which covers web browsing and app loading, the real basic tasks you'd run on a laptop. The 4800U is a double-digit percentage faster, up to 15% faster when compared to something like the Core i7-10710U. In MATLAB, there's not much separating U-series processors, so whether you choose Intel or AMD, it doesn't make much of a difference with the latest version. The sort of performance you see here will also heavily depend on what functions you're running. Single-threaded or memory-limited stuff is close between both platforms, while I expect AMD to pull away if you coded a multi-thread heavy function. In 7-zip, the 4800U gets close to AMD's 45-watt APUs like the Ryzen 7 4800H. The 4800U is much faster for decompression than basically any other U-series part, including AMD's lower core count processors like the Ryzen 5 Pro 4650U and especially the 4500U. The margins compared to Intel are very high, over 2.5 times the performance for decompression compared to the 1065G7 and over 60% faster for compression. In Acrobat PDF exporting, which is entirely single-threaded, the difference between the 4800U and Intel's U-series processors is within the margin of error. In this test, which has historically been brutal on AMD APUs, there is realistically no difference to performance. The Adobe suite continues to be somewhat problematic for Ryzen Mobile, as seen in these Photoshop results. While the 4800U is very competitive, especially at 15 watts, the Core i7-1065G7 is marginally faster when it's allowed to push up to 25 watts. The difference isn't massive, the 4800U is just 4% behind, but you also have to factor in that apps like Premiere have better compatibility and feature support on Intel. There are still issues with color grading 4K videos in Premiere on the Ryzen 7 4800U, which really needed to be resolved before an APU-only AMD-powered laptop is suitable in that app. Then for something like DaVinci Resolve, only really including this for people's interests, while the 4800U is faster than a Core i7-1065G7 in this workload by a fair bit, because the app uses the GPU heavily, you will be better off with a laptop that includes a more powerful discrete GPU. Even something like the 1650 Ti Max-Q is a lot faster. That's not to say the Ryzen 7 4800U has a useless integrated GPU, because for a bit of light gaming, it's more competent than you might expect. In GTA 5, for example, you can achieve a solid 60 FPS experience using the lowest settings at native 1080p, with just 15 watts of APU power. This is a big step up on the Core i7-1065G7 at the same power level. The 4800U is perfect for games like Civilization 6, with enough GPU horsepower to deliver well above 60 FPS using the lowest settings. The CPU is also reasonably fast for things like turn times, and while it's not going to be as nice of an experience as on a proper gaming system, I maintain that strategy games are some of the best to run on ultra-portable laptops, especially those with good enough integrated graphics. CSGO is also quite a good experience on the Ryzen 7 4800U. At native 1080p and using competitive settings, the 4800U delivers over a 100 FPS average. At 25 watts, performance is similar to the 1065G7, but at 15 watts, it's much faster. You can also see here the 4800U beating the MX250 configuration easily. One of the most interesting benchmarks is Gears 5, which is a look at a very GPU-demanding game running at medium settings. The Ryzen 7 4800U is the outright fastest iGPU in this benchmark, delivering a solid result of 24 FPS. While this is clearly too slow for actual gaming using these settings, what it does suggest is the game is fully playable at lower settings or when using the dynamic resolution mode. In my experience, you can get above 30 FPS with a few more things turned down, which is not as possible on the Core i7-1065G7 that averages just 15 FPS in a 25 watt configuration. The 4800U at 15 watts is also able to match the combination of a 15 watt i7-1065G7 with the 10 watt MX250. This suggests that overall, the 4800U's 8 Vega compute units is a more efficient gaming platform than the combination of an Intel CPU with a discrete low-power GPU. You'll also see the performance difference between the 4800U and Ryzen APUs that have just 6 compute units at lower clocks. The 4800U is 25% faster at 15 watts. And finally, there are some interesting things to see between the various power configurations. Ryzen 5 APUs with that 6 compute unit GPU don't benefit much from the increased power limit, going from 15 watts to 25 watts. However, the 4800U does. In this test, we saw a modest 12% gain. Ice Lake gains the most, it saw up to a 35% increase with that extra power available to it. Similar results can be seen in F1 2019, running at the ultra-low preset. The 4800U delivers a very playable experience in this title for an integrated GPU, with a 1% low above 30 FPS. Meanwhile, the MX250 is barely a 30 FPS sort of experience, while Ice Lake at 15 watts is not able to keep up. The 4800U is 56% faster than the 1065G7 in this game at 15 watts. Now let's breeze through some performance comparisons. When pitting the Ryzen 7 4800U up against the Core i7-1065G7 at the same 15 watt power level, the Ryzen processor is almost always faster. In multi-thread workloads, that margin is significant. It's reasonable to expect more than double the performance. But even in most single-thread tests, the 4800U holds a narrow margin. Being over 10% faster in PCMark's productivity and essentials tests is a strong result, given these are common U-series tasks. At 25 watts, the margins do narrow between Renoir and Ice Lake, but not by enough to change much. Ryzen is still more than twice as fast at some multi-thread workloads, and generally faster at single-thread too. Combined with a faster integrated GPU, the 4800U is generally anywhere from a bit faster to much faster for typical laptop tasks. Intel also has Comet Lake U-series designs with up to 6 cores, for more multi-thread heavy productivity. But AMD is able to beat this part too, again with more than 80% better performance in longer-term multi-thread workloads. The Ryzen 7 4800U also has a much faster integrated GPU, around 2.5 times faster than Intel's dated Skylake era design, so the 4800U is a more complete performance package. Compared to AMD's own lineup, the Ryzen 7 4800U is notably faster than the Ryzen 5 Pro 4650U. The jump from 6 to 8 cores, even in the same power envelope, allows for 10 to 30% more performance in typical tasks. This is because adding more cores and running them at a lower frequency tends to be a more efficient design, especially at these core counts. The small 200 MHz increase to boost clocks also delivers better single-thread performance, with the 4800U still being able to hit 4.2 GHz on a single core at below 15 watts of power consumption. In fact, single-core power usage for the entire APU is more like 12 watts, which is very impressive stuff. There is also a big reason to upgrade your laptop configuration from a Ryzen 5 4500U to a Ryzen 7 4800U during the purchase process. The 4800U is at least 10% faster for basic productivity, but up to 50% faster or more in multi-thread heavy workloads. The combination of 2 extra cores and having SMT enabled is a significant improvement for Renoir. There was once a time when, for example, there wasn't much of an improvement between a Core i5 or Core i7 configuration, but here, AMD in their Ryzen 7 tier are producing a strong upgrade incentive. I also want to close this one out with some H-series comparisons. At 25 watts, the Ryzen 7 4800U is generally faster than the Ryzen 5 4600H, which is extremely impressive and goes to show how efficient this Zen 2 APU is at low power levels. The 4800U is also able to trade blows with Intel's Core i9 10980HK. It doesn't always win, but margins are typically below 15% either way, which is crazy considering the Core i9 part is literally the best in Intel's entire mobile lineup. Overall, the Ryzen 7 4800U is one of the most impressive products that I've ever tested. I actually thought quite hard about all the other things that I've reviewed over the years and couldn't really come up with anything that was as impressive at both winning its market segment and providing a huge generation-on-generation performance leap. There are a number of angles as to why the 4800U is so impressive. The big one is that it absolutely destroys Intel's Ice Lake and Comet Lake processors. It's not unusual to see double the multi-thread performance, or better, while also winning the single-thread battle. Throw in an integrated GPU that can be 50% faster, especially at 15 watts, and the Ryzen 7 4800U wins in all 3 major categories for a U-series APU. And again, this isn't just a small win. AMD is utterly dominant in some of these benchmarks. If this was a 100-meter sprint, you'd think the 4800U is cheating with performance-enhancing drugs. That's how much it beats its direct opponent by. The types of margins we're seeing here highlight how efficient AMD's Zen 2 design and especially TSMC's 7nm process node are. On the desktop, Intel can still be competitive by increasing power consumption to match what AMD is doing with Zen 2. That's just not possible in power and cooling constrained laptop form factors. What we're seeing with the 4800U is the combination of a truly generational node shrink with smart design decisions like an increase to CPU cores, which further extends AMD's efficiency advantage. And to do all of this within a single generation is practically unheard of in the CPU market. To put this in perspective, I went back and looked at how many generations it took for Intel to double U-series performance. The answer, based on my Cinebench R15 multi-thread results, is that the Core i7 1065G7 is roughly twice as fast as the dual-core Core i7 5600U from the Broadwell generation. Given Ice Lake launched late last year, it took Intel about 4 years to double the performance on offer. AMD has doubled the performance on offer last year with this year's release, so that's pretty insane. What the Ryzen 7 4800U does with all this extra performance in practice is redefine what an ultra-portable laptop is capable of. Previously, you probably wouldn't have wanted to do any significant data crunching or code compilation on a thin and light notebook. Even for heavy multitasking, those U-series laptops of old could get bogged down. The performance just wasn't there, especially compared to H-series devices. But the 4800U competes with H-series laptops, often getting close to or beating Intel's offerings like the Core i7 10750H or, amazingly, the Core i9 10980HK. If you typically use your laptop for CPU-heavy tasks, why bother with a 15-inch 2kg system with limited battery life, when a 13 or 14-inch 1.3 kg system can offer the same level of performance. Of course, the 4800U and other U-series processors can't fully replace what H-series designs offer. Ryzen H-series parts are still faster again, and then there's the whole discrete GPU situation. 13-inch designs aren't getting 80-watt GPUs anytime soon, and that's where a larger laptop can pull ahead. But for pure CPU performance, AMD is offering H-series class results with the efficiency of U-series. This also puts Intel in a position where they really have never been in the laptop market. Tiger Lake should have been about extending Intel's lead in mobile processors, or at worst case for them, coming in to deliver more performance than what AMD is already offering. With such dominant leads for AMD, now Tiger Lake is more about just catching up to where AMD has been the last few months, before they can even consider offering more performance, and that's compounded by the pressure of Zen 3, which isn't too far away. As it stands right now, there is no way I'd recommend an Ice Lake or Comet Lake product over something from AMD's Ryzen 4000 lineup. However, Tiger Lake is almost ready for prime time, so we'll soon see how the market is shaping up for the holiday season when we get our hands on systems for benchmarking. Either way, it's an exciting time for laptops. We finally have some serious competition, and that's going to accelerate this market like we haven't seen for years. Anyway, that's it for our review of the Ryzen 7 4800U, the fastest U-series processor on the market right now. We will be back hopefully soon to also check out the 4700U, which will basically complete our testing of Ryzen 4000 mobile processors, and then we'll be getting right into Tiger Lake to see how Intel can respond to these parts. They've just announced Tiger Lake recently, and we should be expecting some review laptops in shortly, at least fingers crossed on that one. You never know with the delays for some products in the past couple of months. So, if you've enjoyed this video, please support our testing if possible through our Patreon page. Links to that in the description below. You'll get access to things like our Discord chat, monthly live streams, behind the scenes videos, all that sort of thing. Subscribe for more testing. Thanks for watching, and I'll catch you in the next one.